Yes, I know, my workbench is cluttered. It's like everything. Junk expands into whatever space it can find. Alright, this time I've got a problem. I bought these cheap eBay Hall effect sensors I got two for $10, somewhere in that range. And they advertise them as being sensing on any kind of ferrous metal. And that is not the case. These, in all actuality, require a magnet to sense. I'm not sure if you can see the display. It's reading 11.99 volts, and that's the sensor wire coming out of it. So I've got it wired up to this one, and when I put a piece of steel in front of it, you can see nothing changes on the display. But if I take a magnet and put that in front of it, on one side nothing happens, but if I flip the magnet over, you can see that it goes to 0. So that's the output. So these are 10 to 30 volt DC sensors, but again, you're going to need a magnet to actually use them properly. So if you're trying to buy them off eBay cheap, be very cautious that they don't show a magnet in there, because the descriptions will not include a magnet on most of the ones I saw on Amazon, even eBay. So you need to look for a little magnet, and then sometimes it's attached right to the housing like that, but it's not going to work. So I ended up splurging and buying the do-it-yourself Autotune or DIY Autotune sensors. Yeah, they're overkill, $100 a piece, but you know they're going to work and be reliable because that's what they stand behind. So I got them from Summit Racing. But keep in mind that our sensors are only going to see the edge of the trigger wheel. So when the wheel's going by, that's it. They're not going to see a big flat surface. And these teeth, I'll put the spec up on here, but they need to be, I think, 5 to 6 millimeter wide in the direction of rotation. I want to say 3 millimeter wide thickness, and that's the minimum that they can sense. So you can't have too thin of a wheel. Obviously, the thicker the wheel, the better, but this wheel would normally work. It's just that with these sensors, they're not going to work. I can't have magnets on every one of the teeth. So fortunately, I have some machine tool applications I can use these on, but they're not going to work properly for what I originally intended them to use with the microsquirt. One other thing I forgot to mention, when you're wiring these up, they come with a brown, a blue, and a black wire. And these are European color standards, which make no sense to us because we're used to red, black, and white or green. Brown is positive, blue is negative, or ground, and black is your signal wire. So this is going to go high or low depending on what's happening, but that's the output signal. So it's hard to find this stuff on the internet. I used to work with this in industry, so I'm pretty familiar with it. But I was amazed at how hard it was to find anything just to refresh myself, because it's been a couple of years since I played with it. So just keep that in mind. Brown positive, blue negative, black signal. Usually there's a sticker on the sensor somewhere that tells you how to wire it, positive, negative, and your load, which the load is the signal wire. So they'll have a color code and so on. So if you don't come with a schematic, it's usually right on the sensor. One important thing to look for too is that when you signal that you actually go from high to low. So in this case it went from 13 volts to 0. And that way, if there's any false noise in the circuit, you're not going to get false readings. If there's noise on the circuit and you go from low to high, that could screw you up because you're getting transient voltage. So if you go from high to low, it gets rid of all that transient. It doesn't even come into effect. It actually has to go to 0 or very close to it for the controller to read it. So if you've got a noisy circuit, that's the way to go. It's a personal preference, but it just makes it a lot more precise that you're actually getting a signal instead of getting noise affecting your signal. I received my new crank sensor from Summit Racing, and this is what they look like. One thing I've noted when I was putting the nut on, it only went on about 3 threads and then it stopped. So I'm not sure what was going on there, but I almost thought I had the wrong nuts because they locked up. But a little bit of extra force and they went on all the way. Something I've noticed with these Hall effect sensors is that when you put them near metal, they retract. They've got a little magnet inside. So that being the case, there is an attraction. So this sensor should work, where the other ones I had would not work. You can actually feel them push-pulling when you're getting close to the teeth. Another thing that I thought was important to cover, and it got lost in my other video in the sound guide, was on the crank trigger Hall effect sensor, we're using a 36-1 trigger wheel. So instead of having 36 teeth, there's 35. But that missing tooth, when the controller sees that the sensor doesn't see a tooth for too long of a period, it knows that that's the point that's missing the tooth. So that's why they call it a 36-1. So it knows every time around where top dead center is. The sensor itself, as I showed you before, is going to give you whatever voltage you've got running it, and then when you get close to it with the trigger wheel, we'll go to 0 volts. Now, what's important to note about this is you can see that the signal jumps between 13 and 0. But what you don't see is why that happens, and that's because on the power wire, which is the brown, and the signal wire, which is the black, between them is a 1 k ohm resistor. And if I remove that resistor and then do the same test, you can see that I'm down around 0 volts. But that my difference is still dropping to 0. I'll change the scale here. Go to 200 millivolts. So you can see normally when the trigger is not present, it's up around 9 millivolts. When the trigger is present, it's dropping less than half a millivolt. So without that resistor, we're talking millivolts instead of volts. So you can see how important it is to use that resistor, because putting that in changes the amount of voltage that we're looking for. Now, will the controller work, or a controller work on millivolts? Yes, but any noise in the system is going to really kill you. So what you want is to have a big swing when it goes from no teeth to teeth. Now we're less than 0.2 of a volt, where that wasn't even the high before. So you can see that that 1 k ohm resistor makes a big difference. And the DIY Autotune sensor comes with that 1K ohm resistor. But again, very important to have in between the wires when you connect your wires. So whether you connect them, put this resistor in down near the sensor or up near the connector that goes into the ECU, the microsquirt, that's up to you. So a critical dimension is the gap between the sensor and the tooth. And you can see right now I'm almost touching it. That's touching, still at 0 volts. As I start to draw away, you can see it goes high. Now that still might go to 0 depending on where that tooth is. So as you draw further away, you go high, but it still might sense. It's in an area that's different. So right there you can see that the gap is getting bigger, but there's still a spot where it will go to 0. Eventually you'll reach too big of a gap and it won't work. But you can see there is still a spot there where it goes high and low, even though it's not close. Go a little further out. So you can see it does still read 0 volts, which is what you want when it sees a tooth. Now you can see there's quite a gap in there. I would say at least 3 to 4 millimeters between the sensor and the tooth, and we're still able to see when there's a tooth present. So right there, about 4 millimeter, and we're still seeing. That's 5 millimeter, and it no longer senses. Oh, there's one that does. But if you've got any distortion left to right that's going to change that gap, that's going to really screw you up if you're trying to operate with a big gap. So for some reason, it's at 0 volts. I'm stuck there. So I guess ideally what I'm trying to show is that you want to be as close as you can get to get a good reading off your teeth. The further out, the more critical it becomes. So I would say a couple millimeters is good. 3 millimeters is probably the limit of what I would feel comfortable with. But a couple millimeters is good. I wouldn't want to go as close as 1, because if there's any movement, which there should not be, but just in case there is, you're going to start contacting the tooth and the sensor. So 2 to 3 millimeters is probably about the sweet spot. But again, the way it's set up, if you look at the schematic, you've got the, I can show you here on the power supply. I've got my brown sensor wire hooked up to the 12 volt power, and that's going to one end of the 1K ohm resistor. The other end of the resistor is going to the sensor wire, which is black, and then your ground wire is the blue. So the wire coating is screwy for our standards, but that's the European standard. But hopefully that'll give you an idea of what we're looking for when you use a Hall effect sensor. But again, make sure you've got a good sensor that doesn't require a magnet to be close to it, just steel. That's another thing, is that aluminum will not work, stainless steel may not work. The stainless steel does have a little bit of magnetism in it, but not enough to really work well for this. So you're looking for a steel wheel. I've powder coated mine, and it still works fine. So that's what I would suggest doing, is either painting it or powder coating it so it doesn't rust. But that's all it is. You got a Hall effect sensor. It's looking for some metal to be attracted to. So this is how I have my crank trigger sensor set up. There's about 2 millimeters between the sensor and the tooth wheel. So that should be fine, and you just have to get the wiring connected and put in the wiring looms. But my bracket is just a simple L bracket. I don't know if you can see it or not, but unfortunately I've only got one bolt securing the whole thing, but I can beef that up later on, but for now that'll do. It is resting against the timing belt cover, so it's flush with that, so it won't, as long as that bolt stays in place, it'll be fine, but if it doesn't, it's going to move. So the micro squirt comes with a shielded cable. This one's marked VR1, and that's for the crank. Now the shielding has aluminum foil that's wrapped around the wires. The green and the yellow wire are twisted all the way inside this gray sheath, and then you've also got a ground wire that's running next to them, and that's all to get rid of the transient voltage, the spikes. So this helps keep all the spark plug wires from jumping or creating noise and messing up your signals. And then you've also got a VR2, and the VR2 is going to go to the cam sensor. We'll get into that one later. That'll do it for this week's video.